We are on Unit 8, Day 5, Volume of Spheres. A sphere is basically a set of points that is all the same distance away from another point. So basically what this definition is trying to say is this point right there in the middle is kind of like the center of the sphere, and every point, and it's a three-dimensional shape, but every point around it is the same exact distance from that point. So even like this point, if it was on the front face, that would be the same distance away as one that would be on the top, or one on the bottom, or one on the back side over there. All of the points are the same distance away from the center. The main things we need to know about a sphere is the area, the formula for the surface area. That's one of the two, and then we'll talk about volume in a second. I've already got these problems written out because it's a lot of computations, and I didn't want to spend a bunch of time going through the computations. So you just kind of have to follow along with the formula setup that I'll explain as we go. For the surface area, this first one that we're talking about is the surface area, and maybe I should explain a little bit about what surface area is. Basically, if I wrapped a present in a box, let's see if I can draw a good one here. Maybe not. Okay, if there's a box and let's say a gift is going to be wrapped in this box like that. Okay, if I was getting wrapping paper for it, I would probably look at like how much wrapping paper I would need on the top of it, how much paper I would need on the side of it, and then the same thing on this side, and then the bottom side, and then the back part, and then even this side, right? So we would have to look at all of that information to figure out how much wrapping paper we would need. Well, that wrapping paper is like two-dimensional. It comes on a roll, but when you roll it out, it's like a flat surface like this, right? My wrapping paper would look like that. If I'm wrapping it around, basically this wrapping paper has an area, and that's what we're trying to find. So if we wanted to wrap wrapping paper around a circular object, I think it'd be pretty hard to do because it would get all crumpled and stuff. But let's imagine that it wasn't crumpled, like it was shrink wrapped onto the circle or something like that. That would be surface area. That's how much shrink wrap or whatever you're using to wrap around it. That's how much you would use, but that's two-dimensional because wrapping paper is two-dimensional, for example. As I'm going into example 1, I noticed that it's giving us the diameter of our sphere, and that's 8.4. Our formula doesn't have diameter in it. It has radius. So we're going to use the radius. The radius is 4.2, and I'm basically just plugging that in. So surface area equals 4 times pi times radius squared. So I did 4 times pi, and then my radius was 4.2, we said. So I squared it, and I got 221.6 for my answer. Now they're going to give us another definition here of what's called a great circle. And now a great circle is basically if I were to cut a round object in half, like right down the middle, my great circle would basically be that circle that's made, it's a two-dimensional shape, but it's a circle that's made right here that when you flip it up would look like this. A great circle is a two-dimensional object, but it's just like looking at the top of that sphere if it was cut in half. And you could have your radius, your diameter, or whatever, chords from that, and everything like that. But a great circle is basically a two-dimensional shape. So when we cut that sphere in half, you probably heard this word before, but we cut it into hemispheres. So a half of a sphere is a hemisphere. Let's move on to example 2. It said, find the surface area of the hemisphere. So now we're finding the surface area of a hemisphere, which a hemisphere we said was half of a sphere. So I basically just took my sphere formula, since they gave us the radius on the picture there as 2.8. I put it in my sphere formula, and then I divided it by 2 at the end. And I got 49.2, and this is in centimeters squared because, again, it's surface area, and area is to the second power. Okay, next one, example 3. It said find the surface area of a sphere if the circumference of the great circle is 5 pi. So our great circle, again, was that circle right in the middle, and they say the circumference of that, or you could think about it like the equator of the Earth, was 5 pi meters. Okay, if it's 5 pi meters, then what I did was, first of all, I wrote down my circumference formula. If you forgot what that is, it's right here. 2 times pi times radius. And I set it equal to that 5 pi, because 5 pi was the circumference, it said. What I'm going to have to do here is I'm going to have to solve for radius. So if I solve for radius, I'm going to divide by 2 pi on both sides. These pi's cancel out if you divide them, and you're left with 5 over 2. Like these cancel out, these cancel out. We'll be left with r equals 5 over 2, which is 2.5. And then I took that 2.5 and I put it into my equation, and I got 78.5 meters squared. Volume of a sphere. Now we're moving on to the volume. Here's your formula right here. Volume equals 4/3 pi r cubed this time. And that's something that a lot of my students forget. When we're finding the volume, you got to take it to the third power. The first one, it gave you the radius, and so all I did was I plugged it in. I'll let you guys read that question, but it's just having you plug that in there and getting that out, plugging in your radius. The only thing you need for volume is a radius. Example 5, it says a manufacturer makes decorative globes out of silver in the shape of a solid sphere. Suppose each sphere has a radius of 1.5 centimeters. If silver is priced at $6 per centimeter, how much will the silver cost to make one solid sphere? So we need to find the volume of one sphere. To do that, here's my formula. And they gave me my radius in the problem, so that's what I put in. And I got this out. That is the volume of one sphere. But that's not what the question's asking. The question's asking us to figure out if silver is priced at $6 per centimeter cubed. This would be in centimeters cubed, by the way. All we have to do is multiply that by 6, and we get a total of $84.82. Last example here. Find the volume of a sphere if the surface area of the sphere is 64 pi meters squared. And then use volume for 3.14 and so on. But we're finding the volume if they gave us the surface area. So I set up my surface area formula, and it said that's what the value of it was. So all I have to do again is solve for my radius, because that's, again, the only thing that I really need in order to find the volume. So divide both sides by 4 pi, and we get r squared equals, those cancel, 64 divided by 4 is 16, so that means r must equal 4, and that's what I plugged in. Over here I plugged in a 4 for my formula for volume, and I got out 268.08 meters cubed. That's it for this lesson. Here are your ALEKS topics.